Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Maximum ascending subarray sum, Leetcode 1800. In this problem, we are given an array of positive integer nums and we should return the maximum possible sum of an ascending subarray in nums. A subarray is defined as the contiguous sequence of numbers in an array. That means we cannot skip the elements. So for example, we cannot take the elements in ascending order like 10, 20, 30 and then 50 and skip the elements 5 and 10. And also the subarray should be in the ascending order. So what that means is that each element in the sequence is greater than the one before it. For example, here 10, 20, 30 are in the strictly increasing order, or 5, 10, 50 are in the strictly increasing order. And note that the subarray of size 1 is ascending or strictly increasing. Then in example 1, for the given nums array, we can have many strictly increasing subarrays. For example, these are strictly increasing subarrays of size 1 like 10, 20 and so on. Similarly, this is also a strictly increasing subarray. However, we have to return the maximum possible sum of an ascending subarrays, and this ascending subarray, for example, has sum equal to 60, and this is also ascending subarray, and the sum of this subarray is 65. So the maximum ascending subarray sum we can get is 65, and that will be our answer. Now in terms of solution, one of the naive approach can be that we check all possible ascending subarrays in the array and find the largest sum. For that, we will iterate through all possible starting points of the subarray, and if we find the elements in increasing order, we extend our subarray and add the element to the current sum. However, if the next element is not greater, we stop extending the subarray and start a new subarray from the new starting point. And the maximum sum we encountered throughout the process will be our answer. For example, for this array, we start the subarray with element 10 and then we see element 20. And since it is greater than 10, we extend our subarray. Then the next element is 30, which is greater than 20. So we extend our subarray. Then we see element 5, which is not greater than 30. So that means our strictly increasing subarray streak ended here. So we stop extending our subarray and record current subarray sum as 10 plus 20 plus 30, that is 60. And also update the maximum sum we have seen so far, which is also equal to 60. And start from the next element, that is 20 in this case. Now the next element is 30, which is greater than 20. So we extend our subarray. Then we see 5, which breaks the order again. So we end our subarray here, record the current sum as 50. And our answer so far will be maximum of 60 and 50, that is 60 in this case. Next, we repeat the same process starting from element 30. But as the next element 5 is not greater than 30, the sum for this subarray is just 30. So we move on to 5 and start a new subarray. And the next element is 10, which is greater than 5. Then the next element is 50, which is greater than 10. And now we have come to the end of the array. So the subarray sum we can get from this one is 65, which is more than 60 we have seen so far. So our answer now becomes 65. Then we start the same process from 10 and extend till 50. And we will get the subarray sum as 60. Then we repeat the same process for 50, with sum also as 50. And the maximum subarray sum we encountered throughout was 65. Now in terms of time complexity, it will be O of n square because of the nested loop. And given this problem is easy, this solution may be accepted as well. But you would have guessed by now that we can definitely do better, because you would have noticed we are doing the repetitive work again and again. If you look at this subarray, you can see that first we have this ascending part, then a blip or a disruption, and then another ascending part. So we have a blip over here. So once we have found the ascending subarray starting from element 10, which has sum equal to 60, there is no advantage in starting over from element 20. And why is that? Because in this problem, it is given that all the elements are positive. And if we had negative numbers, say minus 10 instead of this 10, then it would have made sense to consider starting over from element 20 and discard this minus 10. But since all the elements are positive, we simply sum up the contiguous ascending elements. And as soon as we see a break where the elements are no longer in the ascending order, we reset our current sum to the new element, as a single element is an ascending subarray by itself, and start over again. And the maximum sum encountered in this process will be our answer. This approach is very close to Kadane's algorithm for finding the maximum subarray sum in an array, which is already covered on the channel. If you are interested, please check out the I button. So we can take two variables, current and maximum. to track current and maximum ascending subarray sum we have seen so far. And initially both of them will be equal to the first element, say 10 in this case. As in this problem, in the constraints, it is mentioned that the minimum size of the array is 1, but if the array was allowed to be empty, we would have set them to 0 because all the elements are positive. So we start from I equal to 1 because we want to compare each element with the previous element to check if it is greater than previous element or not, and this avoids index out of bounds. So we can see that 20 is more than 10. So current sum will become 10 plus 20, that is 30, and maximum sum will be maximum of 10 and 30, which will be equal to 30 now. Then the next element we see is 30, which is more than 20, and our current sum now becomes 60, which is more than current maximum sum of 30. So we set our maximum sum to 60 now. Then the next element we see is 5, which is less than 30. So that means there is a break. So we reset our current sum to 5, but our maximum sum will say 60. Then the next element we see is 10, which is more than 5. So we add it to our current sum, and now our current sum becomes 15, which is less than the maximum sum of 60. Then the next element we see is 50, which is more than 10. So we increase our current sum to 65, which is more than current maximum sum of 60. So we update our maximum sum to 65. And now we are done with all the elements in the array, and the maximum sum we found was 65, and that will be our answer. Now in terms of time complexity, it will be O of n because we are going through each element only once. And in terms of space complexity, it will be O of 1 because we are using few variables here and there. So now let's jump into the code part. First, let's initialize our answer and current sum to first element in the array. These variables will track the maximum and current ascending subarray sum. Now we will iterate through the nums array starting from index 1. And if the previous element is less than the current element, that means we can extend the current subarray and add current element to the current sum. Otherwise, if the current element is not greater, we will reset the current sum to the current element and start a new subarray. And in any case, answer will be maximum between the current maximum and the current sum, which we will return once we are done with all the elements. Now let's submit this code. Cool. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.